This is Precalculus Concept 8F. This is our final type of transformation. We're going to look at horizontal stretches and shrinks. So the change we're going to notice in this example is again a multiplier, but this time your multiplier C is inside of the function. This is straight out of your book here. Horizontal stretches and shrinks of the graph are going to happen. What happens here though is if you have a C value that's greater than 1, it's actually going to shrink the graph. So our example here on the left, the blue graph is the graph of f, and f of cx, where c is a number bigger than 1, is actually going to shrink the graph down horizontally. Good way to think about that is you're going to divide all the x coordinates by c. Okay, once again, if c is bigger than 1, it's going to be a horizontal shrink. Okay, if c is a fraction between 0 and 1, and you have f of cx, the change for that example is going to be a horizontal stretch. In our second picture down below, the blue graph is f of x. F of cx, if c is a fraction less than 1, is going to cause a horizontal stretch of the graph in every way. Alright, box 2 is an example. I've got the same graph here duplicated twice. It's kind of a semicircular graph. We're going to do two sketches. We're going to do a sketch of f of x over 3 and think about what that would look like, and then f of 2x and think about what that would look like. Okay? So in our first example, I have a multiplier of 1/3, so you may want to view this as f of 1/3 x, just to really see that multiplier. And our multiplier is definitely less than 1, and that's going to lead to a horizontal stretch by a factor of 3. So our point 12,0 is going to be changed, only the x changes. Multiply that by 3, you get 36, and 6 is going to become a new point, 18, 6. Every other point is also transformed. Putting all those together, you get a stretched out graph. It's still going to have the same general shape, but you can imagine just kind of pulling that out from left to right. Your stretch should be away from the y-axis, so the point 0, doesn't change. Alright, our second example is also an example of f of a number times x. In this case it's 2. Since 2 is bigger than 1, you're going to see a horizontal shrink by a factor of 2, the point 12,0. We're going to divide that x coordinate by 2, you get 6, and 6 is going to become 3, 6 here. Okay. Again, every single point in the graph is going to be affected in the same way, and so you get a graph that is a horizontal shrink. Okay. Alright, our third box is a u-try. I've got, again, kind of an unusual function down graph below with a couple points on it. I'd like you to think about what the graph of f of x over 3 would look like. Be sure to show how the given points are transformed. Alright, should see a graph like, or should have come up with a graph like the one shown below. Everything's going to be pulled out horizontally by a factor of 3. The point negative 4 is going to become 6, negative 4, and the point negative 2 is going to become negative 6, 2. You want to be careful about this. Notice that the height, the high and low points of the graph have not changed, so the y values don't change at all, but everything's been stretched out in the x direction horizontally.